Connor, what's the next one going to be? 1/6 - 2. Yep. Integral. Mm-hmm. 6. And then the last one is the same idea. It's going to be the integral 1/6 - 2 from 2 to 6 of what? Negative x squared plus 16 dx. Absolutely here. So on these three, you have a couple things you could do. You could use the Riemann sum program to get an estimate. But what do you have that's better than that? You have the fn in function on your calculator. Do that right now, everybody. Do that right now for each of these things. Find me to 3 decimal places each of these. To each of them. Do them to 3 decimal places, please. V of t. There's your function v of t. It's increasing. Write an integral expression that represents the change in distance and evaluate it for the first second. For the first second. So what would that integral be if I wanted the change in distance? Write an integral expression that represents the change in distance. We haven't been calling it change in distance. Well, we have. What have we been calling change in distance? It's one word that begins with D. The displacement, exactly. We've been calling this displacement. So this is the integral that we're talking about. So for the first second, that's going to be the integral from what to what? So it's just 0 to 1 of v of t. What kind of function is that? Or what does it really look like that function is? It looks like it's a what? Linear. It's a linear function. So do you need your calculator to find the area under the curve from 0 to 1 of this thing? No. Just take a look at that and tell me off the top of your head without writing anything down. Can someone tell me what the integral is from 0 to 1? What is it? 2.5. So 5 over 2. What's the integral expression for the second one? Can someone else tell me what's the integral expression for the second one? Henry, what is it? What's that area right there? Ah, yeah, it has to be the area. The area under the curve. What's that going to be? It's on this. Each of these has the same unit, feet, because it's displacement, it's distance from starting. Feet. It's all feet. Nice. Okay. Time equals 0. The person's distance is 5 feet from home, as in the initial position is 5. Write an integral expression that represents where he is after 1 second. What's his change in distance after 1 second? We figured that out, right? It's what? 5 over 2. What's the integral expression for that? Well, it's right there. So what is this telling us? He's saying that suppose at time equals 0, the person's distance is 5 feet from home. So where is he going to be that represents him after 1 second if he starts 5 feet from home? Yeah, how far is he going to be away? Yeah. 5 more feet, right? So another way to say 5 more feet is a plus sign, right? So it's going to be 5 plus what? The integral from 0 to 1 of, like this, dt. Another way to say that is, what was that 5? That 5 represents the position at 0. Has anybody, who's taken physics here? Who's taken physics? For some reason they use s of t, s as distance. Did you use that in physics? Mm-hmm. Why is it? Because the displacement can use d for a lot of other variables. So it's s. But why'd they go to s? They use a lot of other letters. That's as good an answer as I've ever gotten. So the point is, if you want to know where you are right now, you need to know where you are to begin with, and then have the displacement. You need to know where you are to begin with and then have the displacement. So are the other three going to look very, very similar? Yeah. Well, what are they going to be? It's going to be s of 0 plus what? The integral from 0 to 2 of v of t dt. Well, we know what that is. What is this one equal to? That's 3 over 2, right? And what is this? Oh, that's 5. What's 5 plus 1.5? What's 5 plus 1.5? 6.5, right? So that's going to be 13 over 2. Oh, excuse me. This one is it 5? It's 5 over 2, excuse me, 2.5. So it's 2.5 plus 5 is 7.5, so it's going to be 15 over 2. Mm-hmm. Well, what's this one going to be? Well, we know s of 0, that tells us it's 5, and we know from the other one that what is this going to be? The second part going to be 10. So 10 plus 5 is 15. What's the third integral expression going to be? What's the third integral expression going to be? S naught. Why do I say not? Anybody know? How do you spell not? The integral from 0 to what? It's the same thing here. dt, so that's just going to be 5 plus 45, so it's going to be 55 over 2. And what's the last one going to be? S naught plus the integral from what? Where did I get that from, Nick? I added 5 to this. 5 plus 45 over 2 is 55 over 2. 5 plus 45 over 2 is 50. What is S naught? What is S naught? 5. We're just the problem is stating it as the initial distance is 5. all we're doing is adding 5 to all of these things. All we're doing is adding 5. This is 5, and this one from 0 to 4 of v of t dt. What is this one equal to? Oh, that's 40 feet, so where is it now? 45 feet. So now you know exactly where the car is in relation to home. You need to have an initial condition. What? Why is it 50 feet? Huh? Because it starts at 5 feet away from home, and then the car travels 40 feet. So where is it now?
No, that one's good. I'm saying for 3.
For 3? This one's 5. This one's 45 over 2. 5 is also 10 over 2. 10 over 2 plus 45 over 2 is 55 over 2. Cool. 2 comma 15. The third point is 3 comma 55 over 2. And what's the fourth point? 4 comma 45 over 2. I would like you to take those 4 points right here and graph them for me. So go into the notes. You can copy this over. The 4 points are right there. Plot those 4 points for me. Do that for me.
Why is it 40?
I can almost write 45. For some reason, it's eluding me. Like that's 45. There you go. Graph them here. 1, 15 over 2, so that's what, like 7.5? That's right about what, like right here? And then we're 2, 15. So 2, 15. And then what, 3, what's 55 over 2? What's that about? 27.5? 27.5, so like right here. Oh, is that too high? 27.5 is like right there. And then 4 is 45, right about here. Excellent. And where did it start, by the way? S0 is at 5, right? It was right here. So is this a line? No, it's a curve, right? So what does it look like this curve is going to be? It looks like, I'll use a highlighter here too, kind of looks like this. Kind of looks like that right there. So that right there is not a line, it's a function. Which function is that? That's the distance function. That's the distance from home. This is the distance from home. Distance from home. Yeah, and it started 5 feet away from home. Yes, Nick, exactly. It started 5 feet away from home. So you have point, let's say A, B, C, and D. There's point A, B, C, and D.